This is lesson 29. We've been dealing with distance problems where we had a rate times time equals distance for two people, or mostly two people, and the distance of one person equaled the distance of the other person. In lesson 29, we're now going to add two distances such that maybe for a portion of the trip they walked, and maybe for another portion of the trip they ran, such that we now have a new total distance. So we're going to have two trips, two potential trips, or we're going to have a person taking off from one point moving west and another person taking off from that point moving east. And then at some point, the distance of person 1 plus the distance of person 2 is going to equal this entire distance. So we're going to have to add their distances together to come up with a total. But we're going to continue to build the same table. Look at problem 29.2 on page 132. It reads, Edward and Queen Eleanor. So we have Edward and the Queen. They were 54 miles apart at dawn. Alright, so the Queen was here, Edward was here, and the distance between them was 54 miles. Alright? Edward began a journey to the meeting place. So they're both at 54 miles apart, so that their total distance, once they've traveled and they've met up, the Queen may travel this distance and Edward may travel this distance, but the total distance will be 54 miles. Edward began his journey to the meeting place at 8 a.m. Again, I'm going to write 8 a.m. in the box for Edward's time, at 3 miles per hour. And 2 hours later, the Queen began. So she began at 10 a.m. And they met at 4 p.m. So here they met at 4 p.m. So at 4 p.m., we know that Edward had been traveling from 8 a.m. to 4, which is 8 hours. The Queen had been traveling from 10 to 4, and so that was 6 hours. So the total distance, the distance of Edward plus the distance of the Queen was our 54 miles. And now we can substitute in for the distance of Edward and the distance of the Queen. We can substitute in, I'll rewrite my 54 here, their rate times their time. And we're solving for the rate of the Queen. So Edward's distance was 3 times 8 plus her distance, which was her rate, which is still unknown, times 6 equals 54. 3 times 8 is 24, plus 6 times the rate of the Queen equals 54. We subtract our 24 from both sides, and 6 times the rate of the Queen is 30. Divide by 6, and the rate of the Queen was 5, assuming miles per hour. Yes, 5 miles per hour was her rate. Okay? Now let's look at 29.3. It is going to take practice to distinguish between their distances equaling and having to add their distances. So look at 29.3. Again, I'm going to build my table and know that rate times time equals distance. This is 29.3. It reads, at noon, so at 12 o'clock, Rocket Man, so this is R, whizzed off toward Rocket Land. 1 hour later, so at 1 o'clock, Moonfa whizzed off in the opposite direction at a speed of 200 kilometers less than him. So if we look at the rate of Rocket Land, Moonfa's rate was 200 less than his, so I can say that his rate was the rate of R minus 200. If they were 11,800 kilometers apart, that's the total distance that they had traveled. They began at the same place. Rocket Man took off in one direction, Moonfa took off in the other direction. When they had stopped, they were 11,800 kilometers apart. Okay? And that was at 5 p.m. So we know that his time, he'd been traveling for 5 hours because he started at noon. Moonfa started at 1, so his time was only 4 hours. And the total distance was 11,800. So we know that the distance of R plus the distance of M equals 11,800. And if I substitute in rate times time, then the rate of R times 5 plus, I'm going to run out of space. Let me move this over. The rate of R times 5 plus, now for the distance of M, I'm going to put, his rate was the rate of R minus 200, and it was 4 hours time equals 11,800. I'm going to distribute my 4, and I have 5. I'm going to move my coefficients to the front times the rate of R plus 4 times the rate of R minus, because that's a negative, 4 times negative 200 is minus 800 equals 11,800. I will add my 800 on both sides and combine my R's. So I have 9, the rate of R, equals 11, I got to add them, equals 12,600. Divide by 9 on both sides, and the rate of R is 1,400. Now, if that's the rate of R, then the rate of M equals the rate of R minus 200. So the rate of M, remember the rate of R was 1,400, the rate of M is going to be 1,200. And I have solved for my 2 rates. Now I want to work one more. It's in lesson 30. And it's problem number 3. So it's lesson 30, number 3 on page 139. And it reads, I'll build my table. It says at 10 a.m. little flower. So we have a flower. This is rate times time equals distance. Little flower leaves at 10 a.m. trotting off in one direction at 6 miles per hour. At noon, so that means at 12, laughing boy, the boy, lopped off in the opposite direction. So flowers going one direction, the boys going in the other direction. And at 4 o'clock. At 4 o'clock, they're 68 miles apart. So between the two of them, they've traveled 68 miles. So their total distances is 68 miles. And this happens at 4 o'clock. So Flower has been traveling for 6 hours. That's from 10 to 4. The boy has been traveling for 4 hours, from 12 to 4. And we know that the distance of the Flower plus the distance of the boy equals 68 miles. Now I can substitute in, we'll put his rate, the rate of the boy. The distance is, for Flower is 6, the rate, times 6, the time, plus the distance for the boy is his time, which is 4 hours, times his rate, equals 68. And I can solve for the rate of the boy. So we have 36 plus 4RB equals 68. Subtract my 36 from both sides, and I have 4 times the rate of the boy equals, this is 32. Divide by 4, and the rate of the boy is 8 miles per hour. And that is lesson 29.